Good morning, good afternoon. Today we are continuing working with our Unit 10. Yesterday we worked on PO61, solving those multi-step equations. Remember with the multi-step equations, we had constants and variables on one side of the equal sign, with a constant on the other side of the equal sign, and we simplified it down to one variable equals the constant. So what we are going to be working on today is we're going to have variables on both sides. So how do we get it so it's that one variable on one side equals the constant? So our goal is to move all variables to one side using opposite operations. Remember, we only use those opposite operations if we're moving on the other side of the equal sign. If we're on the same side of the equal sign, remember that first step is parentheses, second step is combining like terms. So when we combine those like terms, and look at that, Mr. Schultz has it right here. When moving terms from one side to the other, remember to combine like terms only. So on one side of the equal sign, you combine the like terms, then you can go between the sides and you only combine like terms. So let's look at it this way. So you have a basketball score of 17-14. It's just like saying it's 3-0. Either way, one side has 3 more points. They won by 3 points. So likewise, 17x plus 1 equals 14x minus 6 is just like 3x plus 1 equals negative 6. One side has 3 more x's. So we have 17x and 14x. There's 3 more x's on this side. Here we have 3x and no x. So there's 3 more x's on this side. Our constants are still plus 1 minus 6, plus 1 minus 6. So even though we're simplifying it, it still means the same thing. So we are going to just be building on stuff we've already done. So there's nothing new in here. It's just adding steps. And remember what I said, we're going to be adding more steps, more complicated equations. It's super imperative that you follow the steps, that you write it out in an organized way so you can keep track of what you're doing. Yesterday, those that I were helping that were having a hard time were not staying organized. You have to write your steps out one after another, and you have to be very consistent with how you write it. So I'm going to scroll up, so this will be easier to work on. Of course, I have to go over to my computer to scroll up because it's never easy. All right, so we're going to do some together, and we're going to show our work. No gold stars for doing it in your head. No gold stars for mental math. Show your work. You will appreciate this when you get into harder equations and you're in the habit of showing your work. It will help you stop making those simple mistakes. So let's look at our first one. 18x equals 14x plus 20. So we want to make it, so we're combining like terms. We want to make it that so we have the variable on one side, the constant on the other side. I don't have any like terms that are on both sides, that are on the same side of the equal sign. So now what I'm going to do is I'm going to combine like terms that are on opposite sides of the equal sign. So I can see I have an x on one side and an x on the other side. So I need to combine those. And when we're on opposite sides of the equal sign, we have to do the opposite operations. So I have a positive 14x. I want to subtract 14x from both sides. So 14x, positive 14x minus 14x cancels out, and I'm left with just a 20. 18x minus 14x is 4x. Now my equation looks like what I'm used to. We've done equations like this before. So I want to get my x all alone. I have 4 times x, so I want to divide, because that is opposite. So 4 divided by 4 is 1, so I'm left with just my x. 20 divided by 4 is 5. So I have x equals 5. Now to check my work, I can put a 5 in for x here and a 5 in for x here. So 18 times 5 is 90. 14 times 5 is 14 times 5. Oh my goodness, having to do the math in my head. 70 plus 20 gives me 90. So 90 equals 90. So I know I did my problem correctly. I can check it on my own. It's fine to come up and double check off of my paperwork, but you can't do that on the math test. So I want you to be checking your work on your own, because when we get to that math test, which is 1 week away, I can't tell you if you did it right or not. So you need to be able to check your work yourself. Let's look at our next one. Negative 10n plus 18 equals 8n. So now it doesn't matter which side of the equal sign I put my variable and which side I put my constant. So sometimes I like to do what's the less steps that I would have to do. So I see there's just an 8n over on the right side, and I think to myself, oh, I can move that negative 10n over, and then I just have my n's on one side and my constants on the other. I could move that 8n over to this side and move my constant over to that side, so I have it as n equals my constant. That would work too. It's just like going to be more steps. So let me show you what I'm talking about. First, we're going to move our negative 10n over to the other side of the equal sign. So I have to do my opposite operations. So the opposite of minus 10n is plus 10n. So minus 10 plus 10 cancels out. And I have a positive 18 equals 8n plus 10n is 18n. Now I want my n by itself, so I'm going to divide by 18. 18 divided by 18 is just 1, so I have n all alone, equals 18 divided by 18 is 1. So I'm going to check my work. If I put a 1 in for my n's, I have negative 10n, negative 10 times 1 is negative 10 plus 18. So negative 10 plus 18 is 8. 8 times 1 is 8. So I have 8 equals 8, which is a true statement. Now I told you we could do it backwards, so we don't end up with 1 equals n. Maybe we want it to read n equals 1. So in that case, we want our n on the left side of the equal sign. So we're going to do our opposite operations. Positive 8 minus 8 cancels out. So that would be a 0. Then we have negative 10 plus negative 8 is negative 18n plus 18 equals 0. Then we want to move our constant over. So negative 18n equals negative 18. We're going to divide. So now we have that n equals 1. See how it's a lot more steps if you want to have the variable always on the left? You might end up with more steps. Same answer, n equals 1, 1 equals n, same answer. Just more steps, more chance that you're going to make a simple mistake with all of those positives and negatives. So it's just more chance of a simple mistake, but you can do it either way. I prefer to do less steps, so I will do whatever's easiest. If I have something like my next problem where I have a variable and a constant, a variable and a constant, I'll do it so my variable's on the left, constant on the right, just because I like the way that it reads better, where the variable equals the constant. But if it's something like this one, I will put the variable on the right side. So it would be 1 equals n because it's easier. But either way will work. So let's do another one together. We have 9y minus 8 equals 4y plus 42. So I'm going to work with my constant first. So minus 8, the opposite of subtracting 8 is adding 8. So that gives me, those cancel out. So 9y equals 4y plus 50. Now I want to move my 4y over to where my other y is. So I'm going to do the opposite operations. 9y minus 4y gives me 5y. 4y minus 4y cancels out. And I have my 50. So now I have 5 divided by 5, 50 divided by 5, and I get y equals 10. I can go back and plug that 10 in for my y's, and I get 90 minus 8 and 40 plus 42, and they both equal 82. So 82 equals 82. I know I did my math correctly, and I got the correct answer. So you always want to go back and double check, did I do my math correctly? It's super easy to put a negative when it's supposed to be a positive. This will help you check that, because I guarantee on those standardized tests, they will have a negative 10 and a positive 10. They will put both answers to see if you understand your negative numbers. So you always want to check your work. Did I do it correctly? Because you'll always be able to rule out a couple of answers as, of course, it's not that. Then you might look and say, uh-oh, did I do my math right? So plug in your answer back into the original equation and see if you get a true answer. All right, let's look at the bottom here. You're going to do the rest of these on your own. You can work with a partner to try to answer them, as long as you are calm and respectful and you're both working, not one person working and another person just copying it down. You both need to be working and understanding. But wait until I'm done with the video before you work with a partner. So equations with variables on both sides can be used to compare two things, such as prices. So a video streaming service offers two plans, $5 per movie or $3 per movie with a $20 monthly fee. How many movies would you need to watch each month for it to be cheaper to become a member? So let's look at how we would set up that equation. So we could have $5 per movie equals $3 per movie plus our $20 monthly fee. That $20 monthly fee is only with the $3 per movie. So we need to decide how many movies, M equals movies, how many movies do I need to watch to make it better to be doing the membership with that extra $20, how many movies make it better to have that $3 per movie fee. So I am going to move that 3m. I'm going to subtract that out from both sides. That gives me 2m. So that would be 2m equals 20 because 3m minus 3m cancels out. Now I'm going to divide by 2. 2 divided by 2 is 1. 20 divided by 2 is 10. So I need to watch more than 10 movies for it to be cheaper to become a member. If I watch just 10 movies, they are equal to each other. I want it to be cheaper, so I need to watch, I could write it as more than 10, or I need to watch at least 11 movies. Because I need to watch more than 10 movies for it to become cheaper, not equal to. If we watch those 10 movies, they are equal to each other, and we don't want it equal, we want it to be cheaper. So you have to be careful with the wording of your word problem to make sure you're answering it correctly. So let me scroll up a little bit more. Word problems can always be tricky, so just be careful making sure you're going step by step on what it's telling you. All right, so here are some equations that may include combining like terms and the distributive property. Ooh, now we have parentheses. Remember, PERMDAS, you take care of the parentheses first, then you do your combining like terms. So my first step is going to be multiplying through the parentheses. So 8 times n is 8n. 8 times 3 is 24, and that's a positive 24, equals 6n plus 46. Now it's like what we were doing on the first page. It's the exact same thing we were doing on the first page. So if you take care of your parentheses first, then you can combine those like terms. So now I'm going to say, all right, take care of my constant first. So I'm going to subtract out my 24. I'm going to have 8n. 24 minus 24. Here I've got 6n stays the same. 46 minus 24 is 22. Now I'm going to subtract out my 6n. So 8n minus 6n is 2n. 6n minus 6n cancels out, plus my 22. So now I'm down to just my n. So 2 divided by 2 is 1. 22 divided by 2 is 11. And you can go back and plug that 11 in, and you'll see that it is the correct answer. So you're going to look at the next one and say, ooh, now I have a bunch of variables. What do I do with that? Well, here's what we're going to do. You're going to no parentheses. So that's our first step, but we don't have any. So now we're going to combine like terms. And I'm going to combine on the same side of the equal sign first. So I see that I have negative 5n and a positive 7n. So I have my negative 5n plus 7n gives me 2n. And I have that 3 plus 2n equals 6n minus 1. So I'm going to subtract out my constant. So I have just 2n. And then I have 6n minus 1 minus 3 gives me a negative 4. So now I'm going to move my 6n over. 6n minus 6n cancels out. 2n minus 6n is negative 4n equals negative 4. So I'm going to divide by negative 4. And I'm going to have n equals 1. Again, if you plug that 1 into the original equation, it should become a true equation. Our last one We do have a parentheses, so take care of parentheses first. PERMDAS, parentheses first. So we're going to multiply that 3 to everything inside the parentheses. 3 times 3x is 9x. Positive 3 times positive 16 is 48. I have to do the math real quick. So then this side of my equal sign, I'm going to carry down as the same. And I'm going to say, all right, let's combine our like terms that are on the same side of the equal sign. I see there's a positive 15x and a minus 8x. So 15 minus 8 gives me 7x plus that 18 equals 9x plus 48. So now I'm going to move my variables to one side, constants to the other. So I'm going to subtract 18. So I have 7x equals 9x plus 30. I'm going to move my variable over to the other side. 7x minus 9x gives me a negative 2x. 30, because those canceled out. So divide by negative 2. Negative 2 divided by negative 2 is a positive 1. 30 divided by negative 2 is a negative 15. X equals negative 15. Notice how I'm lining up that equal sign. I'm keeping it organized on what's on the left, what's on the right. I'm going one step at a time. What am I moving over to opposite sides? First, I do my multiplying my parentheses, and the other side of the equal sign stayed the same, so I rewrote it. Then I combined like terms, and the other side stayed the same. Then I subtract out, or I add, to combine those opposite operation like terms. So keep it organized one step at a time. We're not in a rush. There is no gold star for being done first. You want to make sure you are doing it correctly. So just do one step at a time. When you are done, you take your answer and you plug it back into your original equation to make sure that you're doing it correctly. So notice how in the examples above, the number of variables on each side is different. Something kind of cool happens when there's the same number of variables on each side. Mr. Schultz, what you doing to us here? Adding in something new. Oh, yeah. Let me try to scroll up if it's going to let me. There we go. So we have 8x minus 5 equals 8x plus 1. So we have an 8x and an 8x. Oh, well, I know that if it's the same number of variables, they're going to cancel each other out. So 8x, I'm going to subtract out those 8x's. 8 minus 8 is a 0. 8x minus 8x is a 0. Oops. And then I have my plus 5. So I have 0 equals 6. That can't happen. So what we say is that this is a false equation. There is no solution. So if it happens that you have the same number of variables on each side and we subtract it out and we subtract out all of our variables, then we say it is a 0 and there's no variable. So it cannot happen. So let's look at our next one. Oh, you know what? Here's another way to look at this to know. We know that our 8x's cancel out, so it would be -5 equals 1. That's even easier because our 8x's canceled out, so it was -5 equals 1, which is false. So no solution. Here, we have our 3x's cancel out, and what we're left with is 7 equals 7. So what we say there is this is one of those all real numbers will work. So it's all solutions. Because no matter what we put in for x, you're going to get the same answer. We could put a 5 in for x. 3 times 5 is 15, plus 7 is 22. 7 plus 15 is 22. So it'll always be a solution. So if they don't answer each other, then it's a no solution. If they do equal, not answer, if they do equal each other, then it's all real numbers. So you're going to have to look at the next two. You're going to combine your like terms. You're going to do your distributive property. So you get it down to a variable and a constant equals a variable and a constant. Cross off your variables and decide, is it a no solution or an all solutions? False, all real numbers. So you're going to have to work out those next two on your own. I want you to work on the word problem. Try to figure out what that equation would be and after how many months would the cost of the companies be the same. And what does that mean if they are the same? Remember in our earlier word problem, we wanted it cheaper, not the same. This time we want it to be the same. So think about what the word problem is asking you and how to solve it. Again, I am going to let you work with partners as long as you're being calm, quiet, and respectful, and as long as everybody is working. It's not just one person copying what someone else is doing, because then they are not learning. And we want to be able to walk through and have everybody understand why we're doing the steps that we're doing. So we will go over this tomorrow. So just know that if you're still a little shaky on it, it's okay. We're going to spend some more time on it. But I want you to try and I want you to do your best. And I will see you soon. Have a good day.